Good afternoon, everybody, and welcome to day 4 of reInvent 2025. I hope everyone has been saving up your energy so you can go really big at the party tonight. If you've never been to a reInvent party, it's something you have to experience at least once in your life. But for now, we're going to focus on this session, powering AI and agentic platforms with Amazon Bedrock. So thank you so much for being here with us today. As quick intro, my name is Lowry. I'm on the Bedrock go-to-market team. I work with enterprise and software companies around the world that are building awesome things with Bedrock. I'm joined today by two great speakers. First one is Julia Bodea. She's a senior technical product manager on the Bedrock team. And then last but not least, we'll have Dan Erickson, the director of AI engineering, that will be joining us from Vercel and talking about what they have built with the Bedrock service. So with that, whether you are brand new to the Bedrock service or whether you already have many workloads in production, we've designed the session so that there should be something in this for you to learn from. So quick overview of the session, of the agenda. I'll go over the challenges going from POC to production, then talk about the pillars of an AI platform. I'll do a quick overview of the Bedrock service, and then we're going to dive deep on 3 areas: model switching, evaluation, and observability. And after that, Dan will come up and talk about what they have built with Bedrock, but then also some of the tools they provide to help developers accelerate their path to production with Gen AI and agentic. So with that, let's look at the top challenges and pillars of an AI platform. And we'll start with this quote. An agency or an analyst firm did a study and found that companies and organizations, on average, are canceling 46% of their AI POC projects before they reach production. And you've probably seen variations of this, and there's a lot of chatter about POCs and going to production. And this is my view on this topic. First, I think many POCs are experiments, and they should probably fail and fail fast, and that's okay. But what I'm curious about is those organizations that wanted to go to production, that was their intent. I have 2 key questions. Number 1, what were the reasons that they canceled those projects? And second, what's the remedy or the solution to that problem? So let's start by looking at number 1, the reasons. If any of you have done any building for Gen AI, you've probably experienced some of these and are aware that these are kind of the well-documented problem or challenge areas: scalability, security, reliability, performance, agent management, etc. Like, these are all well known and documented. And you're probably already experiencing some of these and working through some of these things. But I want to dive a little bit deeper on this. And I want to do it based on many of the conversations that I personally have had with many customers, Julia, and many of us from the Bedrock team. We've met with hundreds of customers around the world that have talked to us about this problem going from POC to production. And this is what they've told us. First of all, their platforms are built too static from day one, and they have a hard time keeping up with the pace of change. Next, they're continually worried about the non-deterministic outputs of these models and how to manage that. They also find that it's hard to have visibility into what's going wrong with their application. And then finally, and I think this is the most interesting one, many customers take a traditional software development life cycle and try to bolt on just a little bit of AI, and they find that it doesn't work very well. They really have to kind of radically rethink the way that they develop software and make those features available to customers. And this slide, I think, illustrates that somewhat. Because what sounds really simple from the outset, you've got a product, you're going to download the Boto 3 Python library, instantiate it, call a model, get a response back, and it sounds really simple. But your developer teams might start to ask questions like, what are you going to do about safe AI? What are you going to do about prompt management? What are you going to do about adding custom data in your RAG solution? And so those questions start to compound and end up creating what becomes your AI platform. And this thing is a complex thing to manage. And we understand the challenges related to AI platform management, which is precisely why we built and deployed and made available to you the Bedrock service, which we think is the easiest and simplest way to build and deploy and manage your AI platform. And behind me, these are the 5 pillars of any AI platform. It doesn't matter which cloud you use, which infrastructure you use, which SDKs you use, which tools, which models you use. All of your AI platforms will have most of these, or as you iterate on them, they will eventually have all of these pillars. So here are the pillars. Number 1, models. And notice that it's not just one model. You will have a view of multiple models within your platform. Second, you'll have some form of deployment and orchestration, configuration management. Third, you'll have a data foundation, which brings in RAG and vector database and other data options that add context to your models. Fourth, some form of security and governance. And then finally, you'll have an agentic pillar. So Bedrock is the service that helps you manage all of these elements and pillars of your AI platform. Unfortunately, we don't have time to go over all of those in great detail, but I do want to double click on just one, which is the agents pillar. Because we listened carefully to the feedback that you gave us over the past year plus. Many customers were asking us for better tools to manage the way that they're building and deploying agents. And that's why we launched what's called Agent Core earlier this year. Agent Core is a tool that allows you to build and deploy agents securely at scale with a range of primitives or set of primitives that you can use as building blocks to build just the right type of agent for your AI platforms. So now, with Agent Core and with Bedrock for model inference, you have a comprehensive tool set from which to build all of the right things that compile into your custom AI platform. So if we zoom out a little bit, this is what any AI platform will look like. You have your agent catalog, all of the agents you have your model catalog, which is all of the models that you have allowed listed for your agents and your registry of agents that you've built that can call into those models, and then the orchestration between those things. You'll have a tools registry that your agents can call and that your prompts can call. You'll have a data foundation that add context to your prompts. All of this surrounded by security and governance and safe AI with a great observability platform and an awesome model evaluation framework. So this is what your custom AI platform will look like with Amazon Bedrock. So this is the 3 focus areas for this session today. We're going to go deep on 3 things to help you level up your AI platforms: model switching, evaluation, and observability. And the reason that we chose these 3 things, first, you'll notice that they link back to those challenge areas that I discussed earlier today related to POCs. And then second, because as we've worked with customers that are building and managing these AI platforms, many of them have said that oftentimes these are neglected areas or maybe skipped over areas as they move those first workloads to production, and they have to come back and maybe refine their AI platforms in these areas. So we're going to go deep on these 3. Notice one thing also. This is not a linear development path. These things are interconnected and reinforcing. You can't just develop one without the other. For example, you can't easily switch models if you don't have a great model evaluation framework. And if you don't have great observability tools, you might not know when the time is right to switch out a model. So all of these things are interconnected and really feed into each other. So I'm going to start with model switching. So I think that, at least it's our contention at Amazon, that a tenet for any AI platform builder out there should be that you should easily be able to switch models within your platform from day one. This isn't something you want to try to architect later on. And to support that, first of all, a quick review is one of the key value props of Bedrock is giving you access to an array of frontier models. Whether it's Anthropic, Nova, Llama, DeepSeek, OpenAI's open weights models, whichever models you choose, we give you a range of options so that you can choose the best model for the use case. So the key is that as long as you have this ability to switch models easily in your platforms, then you're able to take advantage of this set of models that are available to you. So if any of you are wondering, why is this model switching topic important? Here are the reasons behind me. Because, first of all, there are hundreds of models that are launched every year, and many of those are deprecated quickly with short life cycles. And so we've been working with many customers where they haven't even finished their dev test cycle, and already they're on a version of a model that's behind. Other reasons, we work with customers that have a product and want to take that product to another region, and when they go to launch in another region, the model that's available in their product isn't available, so they have to switch models. There are also cost efficiencies, performance improvements, moving to the next version of a model for innovation or to beat out a competitor. These are the reasons that you would switch a model. And unfortunately, what sounds really straightforward is actually kind of hard. First of all, there's no such thing as a plug-and-play interface for all models. Each model provider has a different model interface, and each model is built with a different set of maybe philosophical perspectives, so they behave differently. Also, if you don't have a great model evaluation framework, then it makes it hard and costly to switch out these models. So I'm going to go over 3 tools that Bedrock gives you to help you implement this concept of model switching into your platforms from day one. This is the Converse API, the Strands Agent SDK, and Bedrock guardrails. So I'm going to start with the Converse API. First of all, at Amazon, we believe firmly in the importance of developer choice, which is why we give you a bunch of different APIs that you can choose from. You have the Invoke API that gives you lower-level access to models and tools. You have the Responses API, which we launched earlier today, which provides stateful support. You have the Completions SDK for OpenAI that is a direct migration path from OpenAI to Bedrock. And then finally, you have this thing called Converse API. So what is Converse API? It's a unified interface that you can use to call any model in Bedrock. And it provides consistent input and output formats for your models, including standardizing prompts and responses across all model providers. So if you want to start with model switching from day one, Converse API is the API to work with, and it will continue to work with any new models we launch with Bedrock. The second tool we provide is the Strands Agent SDK. So in the same way that the Converse API allows you to switch models, the Strands Agent SDK is designed to be model agnostic for your agents so that you can easily swap out the models within your agents without having to change any of the agent logic and agent code, which is yet another tool that you can start to build with that provides this path to model switching from day one. The last thing I'll talk about is Amazon Bedrock guardrails. Guardrails is a tool that allows you to define and apply configurable safeguards. Things like harmful content filters, PI redax, hallucination detection, deny topics. We just launched support for checking code generation use cases like harmful injection, things like that. And this is applied to both your inputs and outputs so that you can have a single unified safe AI policy for your entire AI platform, regardless of which model you decide to switch to. So now let's see how this works. It's actually pretty simple. If you consider a typical input to a model and then an output that the model responds with, once you have guardrails enabled and a safe AI policy defined, you would apply these guardrails checks at the input and the outputs. And if those checks pass, then your application gets to continue on with the output from that model. If it fails for any reason, that's logged, and your application can decide what you want to do with it. The key is that this works with any model in Bedrock, and also, as illustrated behind me, you can use this for any other model that your AI platform might call. External FMs or even or foundation model or your own fine-tuned models on SageMaker. So these are just a few tools that Bedrock provides to help you implement this concept of model switching into your AI platforms from day one. With that, I'm going to hand it over to Julie to talk about the next two.
Thank you, Larry. So as Larry said, our next section is going to focus on evaluations. First question here is, why are evaluations important? Larry just went over how important it is to be able to switch your models and the number of ways that you can do it within Amazon Bedrock. But in order to switch your models, you have to be able to analyze their performance. You have to see how well of a fit they are for your use case. You want to be able to make the quality, cost, latency trade-off. You want to be able to understand and evaluate for your specific use case and with your data so you can monitor biases and make sure that the model is acting in a safe and trusted way. Easier said than done, of course. There are challenges. First off, you have to find out which model you want to use. As Larry said, there's a whole host of frontier foundation models available for you in Amazon Bedrock, but you can also bring your own RAG system or your own agent runtime or framework. Once you have that, you have to look at your metrics and algorithms. Now, if you don't have an applied science team who can help you understand the different ones, it can be a little challenging to pick. Then, you need to find your data sets. There's a whole host of data sets out there, open source, that you can use, and they're great for generic benchmarking. But that doesn't mean that they're great for your business case and your use case in particular. So you either are going to have to create your own or find one that really works. If you're self-hosting, you have to spin up your own evaluation infrastructure and connect all those different pieces together, which again can be time-consuming and challenging. At this point in the half circle, you have your automated evaluations, but you still need the human element. You want to make sure that you're having a human check, if not the full-blown evaluation results, but some sample of them at the very least for your golden data set, because that's the thing that's going to be the standard for all future evaluations that you do. Once your automated evaluation matches your human evaluations, you can record results and synthesize insights. At this point, you may see that there are a few parts of this process that you need to go and redo. Along the way, you're weighing the trade-offs. You're looking between the quality, cost, latency information that you have, and you're thinking, is this good enough? Is my agent performing at the level and accuracy that I expect for my use case? And if not, may have to go back and make some of those changes. As you can guess from how I'm speaking about it, this is not a one-and-done process. It's very much iterative. You're going to have to repeat this for every single new model that you bring into this system, as well as for your new applications as a whole. Bedrock offers a whole host of tools to help with this process for quality and responsible AI. Some of those tools you can see here behind me. Today, we're going to talk about 3. LLM as a judge, bringing your own model/application, and just announced earlier this week, agent core evaluations. At this point, I know that you're all familiar with LLM as a judge, but as a refresher, instead of using programmatic evaluators like accuracy, robustness, toxicity, or human evaluators like brand voice, tone, style, LLM as a judge is where you can use an LLM to evaluate other LLMs or your RAG systems as if it were another human evaluating them. You can see in the visual that there are scores, visual distributions, and ratings. Again, all done by another LLM. Next, I just want to call out bringing your own inference, because it used to be that you could only evaluate Bedrock models, but that's no longer the case. Today, you can bring your own model, application, or response hosted anywhere. So just so you know, again, you're not subject to Bedrock models only in this anymore. Now, let's talk about agent core evaluations, which has 3 key benefits. First, there's continuous real-time scoring. You can sample and score live interactions with 13 built-in out-of-the-box evaluators. For common quality dimensions such as correctfulness, helpfulness, goal success rate, there's no complex setup or ongoing management needed, so you can quickly get those insights, understand the patterns, and then quickly improve your agent performance. Next, you can build your own quality assessments for your specific use case using custom evaluators, and configure them with your choice of prompt and model. Next, it's fully managed. So those 13 built-in evaluators that we're talking about, again, just out of the box available, they're saving you from requiring you to build your own evaluation infrastructure and managing those operational complexities. I want to call out quickly that Agent Core Evaluations works for agents deployed on the Agent Core runtime, agents running outside of the Agent Core runtime, such as on EKS or Lambda, tools from Agent Core Gateway, context from Agent Core memory, as well as code interpreter and browser. Every single one of these sources are exported as logs in the OpenTelemetry standard format, which are then pulled into a comprehensive evaluations dashboard for easy analysis and real-time scoring. Just to give you an idea of how this works, and again, so incredibly easy to get started, you can pick your evaluators in less than a minute. And again, those are the 13 pre-built ones, or you can bring your own or build your own as well. Agent Core Evaluations is going to call the most performant Bedrock model as an LLM judge for each metric/evaluator that you pick. It's not just going to tell you that something is wrong, though. It's actually going to tell you why something is wrong and help you get that context to be able to root cause and then continuously improve your agent's performance. All those evaluation results are going to feed into Agent Core Observability, which is then used to, of course, continuously monitor and assess and optimize the agents that you have in production. So this brings us to our next big topic of how are you actually observing what is happening within your AI application? Observability allows you to assess system health holistically. It lets you root cause across all model calls and track performance degradations in your applications or your agentic workflows before they're impacting your customers. Now, as everybody knows, observability has 3 key pillars: logs, metrics, and traces. But of course, there are challenges with those as well. First off, there's fragmented tracing. You have to be able to stitch together interactions across your LLMs, your agents, your RAG bases. Second, scaling evaluations is tough. We just talked about the fact that we still need humans in the loop, but they slow the process down. And third, there's a lack of visibility into your agent's performance and if they're really meeting that bar of quality responses that you need. To help with these challenges, there are various tools available to you, and today we're going to focus on 2: Amazon CloudWatch and Agent Core Observability. For logging and visualizing, Amazon CloudWatch has out-of-the-box insights into your application's performance, health, and accuracy, all in one unified view. It has a curated view of all your agents across popular frameworks like the Strands agents, LangGraph, and Crew AI. And it has the end-to-end prompt tracing across LLMs, agents, and knowledge bases, meaning you have visibility, again, into every part of your GenAI application. There are even extended capabilities such as hidden dependencies, bottlenecks, and blast radius risks. But the first thing that we want to call out about this is that it's not enabled by default. Again, not enabled by default, meaning you all have to go in to the CloudWatch console and actually toggle on model invocation logging, and then choose if you want the destination to be S3, CloudWatch only, or both. But if you do that, you get this wonderful dashboard that actually lets you look at the performance about your application and models in one central place. You can see logging metrics like latency, token counts, throttles, error counts, additional filters like timing, tool usage, knowledge lookups. It's fully integrated with CloudWatch alarms and metrics capabilities. And again, this is all just available out of the box. So please go in and enable your logging. Once you start collecting the model invocation logs, you even have access to advanced machine learning tools such as log insights. They let you see patterns across your logs, and then you can better root cause what is happening with your system, and again, take action. Now I want to shift gears to talk about a cool service we launched in the last few months called Agent Core Observability. To assess agent performance, developers used to spend a lot of time instrumenting code using libraries and tools, but that's no longer the case. Today, they can use Strands or another AI SDK to add all of this out-of-the-box functionality. 3 key benefits here. First, comprehensive end-to-end view of your agent's behaviors and operations across all Agent Core services. You can trace, debug, monitor what your agent is doing, and again, maintain that quality of responses that you're looking for. Second of all, real-time dashboards are, again, available out of the box in CloudWatch. You don't have to build them. You don't have to connect your data sources together. You just have to look at them and start taking action. And third, if CloudWatch isn't your tool of choice, you can integrate with whichever tool you want to visualize and track your agent's performance. To give you an idea of how this works, you can send observability metrics from any agent core primitive, as you can see on the left, and any framework, tool, or runtime, even those running outside of Amazon Bedrock. So whether they're hosted on Amazon's EC2, EKS, Lambda, or even on an alternate cloud provider. The metrics all meet in Agent Core, where they can then be outputted to the Agent Core observability dashboards, again out of the box, available, or because the data is emitted in the standard OTel-compatible format, to your third-party observability tool of choice. And you're getting consistent observability regardless of where your agents run. As you've probably been hearing throughout not just the session, but this whole week at reInvent, that is a common theme and one of the main pillars of Agent Core. If you do use the CloudWatch observability dashboards, then they're going to look something like this. You're going to have 360-degree view of your agent workflows, be able to monitor key telemetry metrics such as traces, cost, latency, tokens, tools. You can easily add custom attributes to your agent traces, so again, you can really optimize for your business outcomes and decision-making. And again, you can enable the more advanced analytics for your agents. We're just not going to go through that today in favor of time. However, what I do want to call out and emphasize is that you can send trace info from any agent built with any AI SDK to CloudWatch. So whether that's Crew AI, LangGraph, or the Vercel AI SDK, which we're going to hear about in just a second, as long as that data is OTel compliant, it can be sent to CloudWatch. Here you see a very simple example where an AI agent within an application is using the Vercel AI SDK and the OpenTelemetry library for generating and sending the observability data into CloudWatch via the CloudWatch agent endpoint. It just shows you how easy it is to get observability on your Gen AI application, and as we've been saying, incredibly important, so we can continue to adjust as needed. Now we have a really exciting opportunity to hear from Dan Erickson from Vercel about their AI SDK and how they've been using Bedrock in their Gen AI applications. Dan, over to you.
Thanks, Julia. Hi, I'm Dan, Director of Engineering for the AI Enablement team at Vercel. I've been building AI applications in production since transformer models really hit the scene in 2019. And one thing that's been super clear the entire time is that building with AI comes with its own set of challenges. The ground is moving constantly. We've got new models popping up all the time. We've got new capabilities, new limitations every few weeks. And you have to keep up with that pace of change without rewriting your stack every time a new model drops. Once you ship, you need deep visibility into how these systems behave under real load, not just in a staged demo or a POC. Once you ship, and you need enough confidence in that behavior that you're comfortable putting it in front of your customers, your operations team, your finance team, and not just the early adopters. Today, I'm going to walk through how we address those challenges at Vercel using our own platforms, plus Amazon Bedrock, and how you can use the same patterns to build reliable agentic systems. But first, a little bit about Vercel. Vercel builds open source frameworks and tools like Next.js that gives teams a great developer experience for building web apps, sites, and APIs. On top of that, we provide what we call self-driving infrastructure to deploy and run those apps at global scale. You push to Git, you get preview environments that you can play around with and understand sort of what your changes did. You can merge to main, and then that'll just get deployed out there to a globally distributed production system. You get built-in observability and performance. And over the last couple of years, we've been applying the same philosophy to AI. We build tools and infrastructure that help our customers go from, I've got an idea for an AI product, to this is running reliably in production. And then we keep iterating beyond that. One of the most visible examples of the applications that we develop here is V0. We describe V0 as kind of a vibe coding platform that lets designers, PMs, and engineers prototype by just describing what they want and not sort of writing everything up from scratch. You can chat with an AI agent here about the website, app, or dashboard that you want to build, and V0 turns that into a full-fledged application using AI to do so. That code can then be handed off to engineers, checked into your repo, deployed globally on Vercel or anywhere else. And so you can get the speed of AI-assisted prototyping with the safety and control of real code that's driving the app. Because we already also sit sort of in the path of your code, your builds, your production traffic, we're in a good position to help you find and fix issues too. Vercel Agent is our agent for code review. It reviews your pull requests before you deploy, highlighting potential bugs, regressions, finding any anti-patterns that you might find. And once you're in production, it can investigate anomalies in your logs. It can dig into your logs and traces, follow them all the way through your stack across different projects, and even help get to the root cause faster. The same agent can span that full life cycle. So don't ship this bug all the way to here's what broke in production and why. We also think that agents shouldn't just live inside engineering tools. Similar to Microsoft's old a computer on every desk vision, we believe that over time there will be an agent helping almost every role in every company. So we're building internal agents across Vercel as well. Our go-to-market team uses agents to help qualify leads, spot expansion opportunities, etc. Our finance team is exploring building a procurement agent to help streamline new software purchases. Our data team built a Slack bot that lets anyone in the company ask BI questions in natural language and get answers backed by our data warehouse. It's the same underlying platform for all of those things, all of those different use cases and different stakeholders. The common thread across all of these is Amazon Bedrock. We use Bedrock as the foundation for our AI and agentic workloads. It gives us access to a range of high-quality foundation models with all of the security, compliance, and scalability that we need as well, while still letting us experiment quickly and swap model capabilities or models as capabilities improve. Every example I've mentioned so far, and the ones that I'll show next, are powered by Bedrock under the hood. So, how do we manage to build all of these products and agents so quickly? Part of the answer is Vercel itself. Our own teams use the same workflows that we give our customers here. V0, for instance, is just an app that is deployed on top of Vercel. Same with our Vercel agent. So our teams get to get all the nice DX of building apps on top of Vercel itself. But the real secret here is the AI-specific tool set that we've built on top of all of this. It's a set of building blocks that make it easier to design, monitor, and operate agents in production instead of hand-rolling one-off scripts every time. When we started building V0, we knew the model landscape was going to evolve quickly. We didn't want a new model coming out to mean that we had to rewrite half the code base every time. So we built a clean abstraction layer on top of that lets us write our application logic once and then plug in different models and providers underneath. That became the Vercel AI SDK, which we've open sourced, and so all of you can try it out. But the AI SDK gives us and you a great developer experience for building AI chats and agents. Structured tool calling, human-in-the-loop flows, streaming responses, and agentic loops are all first-class primitives in the SDK. It has observability built in, so you can see how your prompts and tools are performing. It works seamlessly with Bedrock models as just another backend. So from the app's perspective, talking to a model on Bedrock or going out to OpenAI or Anthropic directly or wherever, it's all the same code that you're writing, and it can just kind of swap between all those things. Of course, once you actually have these things running in production, you need a control plane to be able to understand what's actually happening in production here. And for that, we built the AI Gateway. It gives us detailed visibility into how all of our agents interact with models across all of our different providers. The gateway tracks every call to every model, which agent made it, what the latency and costs were, and how to use those metrics, or how those metrics changed over time. Because it sits in front of any provider, it also gives us a safe way to test new models as soon as they're available. If OpenAI launches a new one or a new model hits Bedrock, we can very easily just swap out a string and start playing around with the new model. That observability and routing layer is key for running AI systems at scale. The AI SDK and AI Gateway were enough for us to build simple, short-lived agents like chatbots or quick little helpers. But when we started to really build more complex workflows, like the Vercel agent for code review, we needed something that could handle long-running background tasks while still scaling like our familiar serverless primitives. So that's why we built the Workflow Development Kit. At its core, Workflow Development Kit is a compiler layer on top of TypeScript that turns any TypeScript function into a durable workflow. You can mark the orchestration function with just a use workflow directive, and we'll see an example of this later on, that basically turns it into a pausable and resumable TypeScript function. You can then add use step directives on any function that is called within that, to turn that into an asynchronous, queue-backed, durable step. So the result is what we call self-driving infrastructure for AI agents. You write straightforward TypeScript, and Workflow Development Kit figures out how to deploy, run, and resume all of that behind the scenes. So at a high level, that's how it all works. Now let's actually go deep into some of this and develop a real example here. So we're going to start with a very simple text generation and incrementally turn it into a durable tool-using agent. So here's our starting point. It's a simple one-step text generation. You'll see that generate text there is a few simple lines. We're just pulling in the generate text function from the AI package, and we're pulling in Bedrock, or the Bedrock provider from there as well. So basically, this is just going to send a single request out to, looks like this one is Sonnet 4.5, and it will answer that question for us. However, so this is just using sort of like the built-in knowledge within the Sonnet 4.5 model. So it probably doesn't know about like all the stuff that was just announced this week. So to fix that, we're going to want to turn this into a tool-using agent. So let's do so. All right. So here's an example of a tool calling agent that can use a browser. We're importing the browser tools from Agent Core, which were, I believe, announced this week. Basically, browser tools is a way to spin up a browser in the cloud and allow the LLM to actually pilot it. Bedrock actually provides Vercel AI SDK compatible tools for these that you can just use inside of the AI SDK itself. So instead of directly calling the model, now we're going to ask the agent to just generate an answer there. You'll see we create a new tool loop agent here. We give it some instructions. We give it the browser tools, and then at the bottom there, we actually ask it the same question there. So it looks like a simple function call here, and it works exactly like that. All right. So let's add another tool in here. So we can turn this thing into an analyst, right? So instead of just giving it access to a browser, we're also going to give it access to some code interpreter tools. So maybe now it can go out and do some sort of deeper research for us. It can go spider through all of the different docs for Agent Core, and let's see, what are we doing here? We're counting up the number of tools. So it's gonna, do some code, write up some code to do that calculation for us, and then pop that out. So it's as simple as just adding the new tool to the system here. So the trade-off here, though, is that now we're asking this agent to do a lot, right? It might be going out there and using the browser for multiple minutes at a time. It might be writing up some code that could take a little while to author, and then it has to wait for the code to actually execute as well. Traditionally on Vercel, we are fully serverless. So it's using Lambdas roughly under the hood. But as we all know, those have timeouts. You can't go forever on these things. And so in order to allow this agent to run for longer than the serverless timeout, we need to add some durability. So let's do that. So we're going to make this agent durable with Workflow Dev Kit. The way this works is we are swapping out that tool use agent for a durable agent. This is a one-to-one mapping between the two. And you'll notice we're pulling it in from the Workflow Development Kit here, not from the AI SDK. And what this does is allows you to wrap it in a workflow orchestration function. So you'll notice the use workflow directive at the top of that. And then any tool use that happens within this durable agent that is decorated with a use step in the execution path will then be executed as a durable step backed by a queue, retriable, and with observability and error handling built in. The cool thing about the agent core tools specifically is they actually all have that use step baked in already. And so one cool thing about the Workflow Development Kit is it allows you to just install these things from NPM and use them off the shelf. You don't have to make them durable in any way. These things played really, really nicely together. So that's the combination we care about, right? We want an agent that can talk to these LLMs. We want to be able to swap out the models really fast. We want to be able to orchestrate the tool use and give it instructions and understand which tools it can use there. And then we also want to ensure that these things can run in a durable fashion. So that's what we care about. Bedrock-powered reasoning, a rich tool ecosystem, and durable orchestration that feels responsive to the user. So, to recap, we use Amazon Bedrock as the model platform for our agents, Vercel's AI SDK and AI Gateway to build and observe them, and the Workflow Development Kit to make them durable and production ready. The patterns I've showed you here are the same ones that we use for V0, for Vercel agent, and for all of those internal agents that I was talking about. So I'm excited to see what you build. Back to you, Julia.
Thanks, Dan. So to summarize, in our experience and from what we've heard from you, once you get the first application out, there are 3 areas that are usually neglected or that you want to improve upon. Those are the 3 areas that we wanted to focus on today. But the point that we want to leave you with is that it doesn't matter which tools you're using to do these things, whether you're using a third-party tool, you're writing everything on your own, or you're using Amazon tools. What matters is that you're picking the latest and greatest model that is best for your use case. Second, that you're evaluating those models in a data-driven way. And third, that you're observing how the performance is changing over time, and you're adjusting as needed. To close, we leave you with this important takeaway. Confidence that building with Bedrock will give you access to all the latest models, features, and innovations that you will need to continually iterate and up-level your AI platform. Just this year, we've added over 30 new foundation models, launched Agent Core, and a range of new features, with a lot more to come in 2026. With that, we look forward to the awesome things that you will build with Vercel, Bedrock, and Agent Core. Please feel free to check us out on the Amazon Bedrock webpage and an AWS Skill Builder. I'll leave that up for a few seconds in case anyone wants to grab any links. I see more phones going up, so giving an extra 1, 2, 3. Wonderful. As a reminder, we so value your feedback. It's how we continue to get better, so please, before you head out to your next session, leave us a review in the survey and let us know what we can do better next time. Thank you for spending this hour with Larry, Dan, and I. We will stick around a bit for any one-on-one questions just off to the side here. If not, enjoy the rest of reInvent. Have a wonderful time tonight at Replay. Safe travels home, and we're wishing you a very happy holidays. Thank you guys so much.